Sounds good.
Are you on mobile? It should be under more, maybe.
No, I got it. I got that.
Okay.
Okay, so let me, yeah. So I'll just open the screens or the videos also on the right side. So just in case if you feel that you are having any question. So what we'll do is that since the material or since the topics that I'm covering includes a lot of details and, you might be having questions, for each of the slides. So it's up to you that you can either record it on your, you can either note down on your, or you can have your notes, or you can ask me once the presentation is over. It's purely up to you, So we want this to be more engaging, more interactive, not just like going through all the topics. Okay. So I'll not be introducing myself. I think most of you know me. So I'll just quickly go to the agenda. So what we'll be covering? We'll be covering blockchain vulnerabilities and security fundamentals first, because I feel that to understand the blockchain vulnerabilities, you have to understand the basics first also, that, how much, let's say, how much security is enough, or what sort of dimensioning that we need to do for the security in terms of blockchain. Yeah. So to understand all of this, I'll just go through a brief about the fundamentals of the security and how we can position blockchain once we are building any architecture with this. And then I'll just briefly describe about the top 5 attacks on blockchain with samples, like, how those attacks were actually initialized, what is the impact of those attacks, and how we can prevent those attacks. Then to understand, actually the further we need to understand the flow of the data, that how data is entering into the blockchain system and how data is going out, so that we can know our attack vectors, which attack surfaces we need to protect. There I'll be discussing about blockchain security domains, that if we need to, architecture blockchain, if we need to, build an architecture around it, what sort of domains that we need to segregate, we can segregate the blockchain on, and then what sort of risk management that we can deploy around those domains. Okay, and then, just a brief about a high level overview about, how you can deploy blockchain securely, like the life cycle of all that process. So yeah, pretty exciting. Okay, so blockchain vulnerabilities and security basics. So if I may ask you, anyone, when we talk about security as a process, what do we exactly mean by this? Do we mean that I should, once building or doing any software development lifecycle, I should embed security in each of the steps? Or let's say that if we're talking about security, so how much security is enough for us? What do you think, just on high level? Or if I may start with Mark. What do you think, Mark, about once we say security as a process, what do we mean by this?
Yeah, I think you pretty much have to think of it along every step of the way. Certainly when you're activating a smart contract, you're pulling typically some JavaScript off a server, and then you're running it. You're not going back to that server, so now you're pushing it to whatever blockchain you're working with. So you have to deal with the messaging, I think, all the way. So I would imagine there's a vulnerability there. Once you're on chain, that's an interesting question, because once the actual network is using, for example, Ethereum is using the wire protocol to reach consensus and to settle and to transact, that's outside of your ability to control. So that's an interesting question. So I would imagine the interfaces would be the weak points.
Okay, very good, very good. And if I like to have if I need to answer this thing, Yani, in my network, if I'm a blockchain solution architect or if I'm a project manager, how much security would be enough for my system? How will I get to that point? What do you think? Anybody can, or would like to comment on this, that in any system, how much security will be enough? Or can we have enough security? I'd rather put it like this.
I think it depends on the use case. So maybe if you work backwards, see what, like for example, the NFTs that I'm going to to distribute at the end,
Mm-hmm.
they have very low security because they use XDAI. XDAI is a
Mm-hmm.
sidechain of Ethereum,
Mm-hmm.
and its use case is specifically for things that don't need high security, and it's able to
Mm-hmm.
do that really fast and with low gas.
Okay. So, I mean, it depends on the use case and it depends on our risk management process. Like how much security do we need comes down to the risk analysis or the risk management that we are doing, which is like identifying the risk, do some quantitative and qualitative analysis, then see that if the risk that I'm going to solve, because solving risk comes with a cost. You need to have a control, you need to spend some time, you need to have the resources, so if I have to protect my asset which is of like $10, I don't want to spend on the security control worth of $100. Yeah. So you need to have a trade-off or a business case to deploy the security process and the tools, to protect your data or to protect your assets. So this process goes like you need to have your proper risk assess for this use case, and then you need to figure out that how much security is needed. Okay. But as a bottom line, just enough security to protect your assets. We don't need to spend too much on that security, on that asset which is of less worth. Okay. Then the second point is CIA tried. To actually position ourselves, like what sort of things that we need to secure, or to actually dimension our network, we need to focus on three things over here. Okay. Or in most security architecture you will go through, they will either protecting one of the three things. Okay, so the first thing is confidentiality, which is privacy. Like if, for instance, if I'm sending one thing to Alexi, he's the only one he should receive it. Okay, nobody else can intervene that communication channel. Okay, then it is integrity. What is integrity? If let's say if I'm sending one file to Mark, okay, that file needs to be intact and it doesn't need to be modified. Okay, if it's modified in that sending process, if I'm sending a key, for instance, or any document, okay, that the integrity needs to be protected of that. Okay, then it comes availability. Availability is like, if I'm having, let's say, 4 nodes in my system or in my architecture, 4 nodes, if one of those node becomes unavailable due to a denial of service attack, or any or it increases the bandwidth or something goes wrong to that server, so that machine goes unavailable, so the data or the resources that it is being processing will suffer loss. So if we need to dimension the security the architecture, we need to focus on three things in order to protect our system. So once we talk about protecting confidentiality, it means that I should be having, let's say, asymmetric encryption. Okay. If I'll be to protect integrity, I'll be doing some hashing. I'll be using SHA-256 hash, to make sure that the document I'm sending is intact. Okay. If I'm thinking about availability, it means that I'll be having enough redundancy in my architecture so that if one device goes down, okay, I'll be having enough resources to actually or shift my traffic to. So the whole security comes down to the CIA thing. All right, makes sense? Okay. Now the third thing is defense in depth. Now tell me that if I need to deploy the security, what sort of things would be enough for me? If I'll be giving you example of a house. Okay, if you have burglar alarms, let's say, or if you're having a good scan for your face scanners, would that be enough? What do you think? Or if I'm having, let's say, CCTV cameras, or if I'm having a dog, a guard dog, to protect my, or protect my house, would that be enough? So
Yeah.
if I'm having multiple layers of security, it can delay the attack, or it can prevent my attacker to just catch my thing. So in order to protect my network, I should be needing multiple controls in multiple layers, to have adequate security. Okay. And that also comes down to the risk management, that if I'm protecting the higher asset, I need to have multiple different controls around in my network. then we should be having simple security. We should not be trying something which is non-tested algorithm, let's say. Or you can go like, if we're having multiple data input points, okay, I'll be expanding my attack vectors, or imagine that if you're having a house which is one gate, so that is more vulnerable, or if you're having a house with, let's say, 5 or 6 gates. Okay, so once you're building the architecture, think about putting like less attack vectors, or the algorithms or the control that you have tested, and which is simple, because if you're making it complex, it will be harder for you to protect. Okay, then comes down to blockchain. Blockchain vulnerabilities. Okay, if you're talking about decentralization, okay, once we think about security, we talk about governance, we talk about incident management, that okay, once we have any attack, how we will respond to that attack. Okay, we should have something like, we should be taking care of the forensics, like, if we need to prosecute an attacker, I need to have a proper chain of custody of my elements, so that is this decentralization. But if you're having a decentralized network, you have to have a trade-off for all of these things. How you will set up, let's say, for a governance thing, you usually go for an ISO certification or a corporate certification, which will give you that what sort of policy that you need to have it. Okay, what sort of procedures you need to have it if you have any attack. But with decentralization, you'll not be having all of those things. Yeah, so you need to take care of that. If you're going with that system, how you will control all of these things. Yeah, okay, so do you have any questions up till now, or are we good?
Yeah, all good from me.
Okay,
I have a question. It might be a bit detailed at this stage, but something to think about. In doing some smart contract coding, what struck me is how much you rely on third-party modules to actually generate the code. And for example, you would download something from GitHub or from Node.js and just use it. You just use it in your and you'll see there that it's developed by some random guy who's just developed this thing and made it available. I mean, what are you doing at an enterprise level with this stuff? Because I mean, do you just trust the stuff? Because the world is just full of it. It's just you just need these packages to plug in, and then you write your code and you deploy, through a conventional website. And that's where, I mean, I don't understand how you manage those risks.
Yes, actually, Mark, yeah, this is a very valid point. People don't usually care about these things. They just want a working software or something that they can deliver early to the market. Okay, what we don't care of that or we only care once something bad happens to us. That okay, now we need to take care about security. Now we need to have adequate measures, but that is all gone. You already are losing, or so many of your customers. So why not doing security or putting security upfront? So when we talk about, so earlier we talked about security as a process. This means that from the project charter, from like the project initiation, you have to have a security requirement that what are you protecting. Okay, you need to have the proper data classification for each of your points. Okay, then you need to put this into each, like say that project management. How will you procure your third-party, systems? Okay, what sort of access control mechanism you need to have it. Yeah. So if you think security as a process, it will make sure that once you reach to that smart contract auditing or the development phase, you will be taking care of all those aspects also.
Yeah. Okay.
So moving on to smart contracts, we have seen numerous times as an examples or in the news that those smart contracts were having bugs. There are so many vulnerabilities that happen. So I'll give you two things over here. For each smart contract, check lines of code. How much lines of code are there? Because this lines of code will gives you defect density and risk density. Okay. So if you want to evaluate the smart contract, check that what sort of errors, let's say that buffer overflow or reentrancy or anything, how they're evaluating, how they're doing unit testing. Okay, how they are making sure that what sort of testing tools that you need to have it. So once you talk about smart contract, it needs to be properly audited.
Okay, the lines of code should be proper evaluated with some actual load on the system. Okay, and the known attack vectors that we see in the smart contracts, okay, needs to be evaluated. Okay, then talking about endpoint security, usually once we talk about centralization system, okay, we are having a security governance model, then we are having policies, procedures for all of those governance models things, and then we have the resources. But with blockchain, uh, we are giving more control to the developer or the end users. Yeah, so the training programs, like how your users will be going to access your system, needs to be properly documented, or at least, I mean, they should know about like what are the attacks that they can face. So we have to have a proper plan for security and training for our end users, and also for the developers, that what sort of things that they need to focus on. If they just want to focus on the code and the working software, this is not enough. So we need to focus more with endpoint security with respect to blockchain. Then talking about cryptographic keys. Over here, you need to understand this thing. Once we're talking about crypto or cryptography, it looks very amazing that we are having asymmetric algorithm, we are using encryption, we are using this blah blah blah. But what about the life cycle of the keys? Like how you are generating the keys? Okay, that's one. Is it like an in-house device module or an algorithm which is giving you the keys, or you're relying on, let's say, a cloud HSM, which is giving you the keys? Okay, you need to make sure that how you're generating the keys. Okay, the second point is how you are storing the keys. Where you are storing? You are storing in your device, or your mobile phone, or a cloud server, or a vault. Where you are storing your keys. Okay, then the third point is, if let's say if you are sharing the keys, how you are sharing that keys? Are you using any authentication mechanism to share the keys, or just giving randomly? Okay, then if you need to destroy the keys, how you destroying the keys? Okay, because see, our users may not be familiar about all of this process. Okay, if let's say if I am putting my cryptographic keys on my mobile phone, and in my mobile phone is hacked, okay, the users can steal my private key, and they can unlock my funds. Yeah, so if I'm putting my keys on the mobile phone, make sure that it is encrypted. Okay, or if I'm even putting on cloud or any other third party, that also should be encrypted for all the data at rest, which is like the storing thing. And also if it's been going on transit, that's whole path needs to be encrypted, for your keys. Okay, so for the top 5 attack vectors, okay, the first attack vector is the network design and vulnerability, because with centralization, with decentralization, we are not having enough measures for like access control, or we are not having firewall in the right position, maybe, or if we are, using any third-party applications, we are not protecting the ingress or the, the inflow or the outflow of our, data. So the network design that we are, architecting needs to be protected, but this seems to be a vulnerability when it comes to blockchain. Then we see that exchange attacks. We are not, this is not getting, all this is self-explanatory. We have seen different exchange which has gone under attacks, and why? Because they're not following the adequate measures. Where I mean, they are having a hot wallet. They're storing all the keys on their wallet, which is connected with internet. Yeah, so this is what makes them vulnerable. And also, if there is any attack, they don't have any incident management plan to actually counter that attack. What sort of response that you need to give it, or how much you need to contain it. How you will be putting, let's say that if your DNS of an exchange is attacked, how will you inform your users or the media about it? So these things are lacking in this one. Then phishing, social engineering. If let's say if I'm no matter how much we create awareness, but we will still be clicking some links which will redirect us to some bad, some other places, which is like will be inputting our passwords, all of this thing, and that is all under hacked. So that is how we. And then if the user is putting, let's say, his username and password, he can disclosing his password. So this is all need to protect through all attacks. And then the fourth attack, or the fourth attack vector, is the malware. So imagine that if you are clicking a link, or if there's any attack which is your browser comes under attack. So you need to have your browser or your cookies can be stealed, and then your browser will be mining cryptocurrencies. So you need to protect that if you don't have any malware in your system, because malware, what this does is actually a small worm which stays on your OS, and it only activated upon some triggers of some special events, and how you can figure out this thing, you can simply go to your taskbar, and if your CPU is high utilized, you can think of, okay, something is wrong with my OS, or I've been attacked, so you need to have proper anti-mining. You need to install extension on your browsers, and you need to constantly check that of your performance of your system, that maybe your system is under attack or not. Okay, then software vulnerabilities, we all know, like buffer overflow and reentrancy. With buffer overflow, let me give you one example. Okay, so do you have any question up till now on this one?
No questions, just a lot of process, to be honest.
Okay. Okay. So buffer overflow, there are two software attacks which you usually face. Okay, buffer overflow is a software vulnerability. What it has, if I'm defining, let's say, unit A is equal to 255, it can have, this variable can have, let's say, from 0 to 256 number of things, or the characters, you can say. Okay, but if I'm putting, let's say, A++, which is exceeding this limit, it can goes to my other memory locations, and it can be a small injection, or it can be a malicious payload, or anything which can cause my system as a denial of, so having a denial of service thing, or let's say or can be escalation of privileges. So anything which is, like, say that if I'm having this buffer for my variable, and if I'm, let's say, the attack has a payload which is been incrementing this original buffer, then the overflow will occur, and this maybe can be a malicious code, okay, or it can be anything which is taking care. If, let's say, there's another program installed over here on another buffer, so it can cause trouble for that position, for that, or for that, or for that next memory position. So you need to take care of that. You need to have proper mitigation strategies, that, for instance, that if something goes overflow, it should goes to a failure or to the safe failure mode, that it should fail that thing, and it should give you, let's say, a blue screen which you see usually on your OS when something goes bad. So it's like a dead screen. You should not be doing anything more. Okay, if it comes under attack, or if that or if your OS goes under that attack, or your code, then it needs to, you need to have, or memory isolation, for that. If there is some overflow occurred, then that space needs to be isolated. Okay, then what it can cause? It can cause denial of service, it can cause malware, and in case, and it can also be an injection attack, in which it can either go into your DB or into your other layers of your architecture. Okay, so you need to take care of all these things. And once you review your code, you need to ask them that what sort of mitigation strategies that your developers are having for buffer overflow. Okay, the second attack is reentrancy attack. Okay, this one, if, let's say, if I have this original contract over here, okay, and if this contract needs to have an external calling function from this external contract, if, let's say, if the A has, which is the DAO, A has, let's say, 10 ethers, okay, and A has borrowed, let's say, 8 ethers from this contract, okay, and if it needs to ask, okay, this A, that please give me money back or give my ethers back, then it will call an initial withdrawal function over here. Okay, when this function will occur, okay, ideally what happens, that the ether will transfer to this account, which is an external account, and then the balance needs to be updated over here. Okay, but instead what happens, that it will again call the withdraw balance function over here. So it will keep on running this loop until this balance, or the balance which is which this DAO is having, is exhausted. Okay, so what is the attack vector over here is that you need to properly, once you call any withdraw function or withdraw balance, you need to first update the initial input about and fully complete that life cycle before you execute the other second function. Okay, because in this way it will keep on running withdrawal function, and it will not be updating the balance. So that is, so in this way, imagine if DAO contract has, let's say, 10 ethers, all of that 10 ethers can be given to this external contract. Okay. So this reentrancy and buffer flow for all these two attacks needs to be taken care of. And what this can cause, it can cause a limited withdrawal. And this, by the way, this DAO attack actually occurred in 2017, and $3.4 million or 3.4 million dollars were lost in this. So that is they eventually did a hard fork to actually overcome this attack, overcome this flaw.
Is this the one that was caused the Ethereum Classic blockchain
Exactly,
to be?
Exactly.
But I mean, Taha, it seems that these issues that you just described, they should be nowadays somehow handled as kind of standards inside the way smart contracts are being programmed. No, I mean, if some things like these occurred, people who are now in charge of programming these kind of DAOs, they should be knowing about these attacks that have happened in the past and tackle those, right?
Yes, exactly. I mean, see, we cannot protect everything, or we cannot expect that we should protect everything. But what we can do instead, we can do our due diligence in order to make sure that what has been occurred previously should be taken care of. And if we have, if we can do some throttling or techniques, or do some analysis of our architecture, we can find out some of the attack vectors more. So, but as much as we can, we need to make sure that what we can do, we should do this thing. Okay.
Yeah, and often the developers are actually the same person as the malicious actor. So they're purposefully making these re-entrancy possibilities in the backend so that they can exit scam later in a project.
Actually, there is.
But then
that's why it's very important to make sure, if you're investing in some project that you believe in, that it's been audited by an external third party.
Or, I mean, even better, I think, is when you open your stuff up for bug bounties. I think if you have this kind of ability to just check your whole code against the world instead of one specific audit company, I think there's even more chance that people will identify stuff like backdoors, no?
Yeah, the bug bounty
Exactly.
If you have engagement. If you don't have a big community and you're just a startup, then your bug bounty will be, really
That's
weak.
true, but I mean, in the smart contract world, how much money do you have to spend for a proper audit? I think maybe it's comparable in terms of cost to launch a bug bounty or to engage with an audit company, no?
Yeah, I don't know, Taha, you can correct me, but I think from 5,000 ranging to about 50,000. And then there's also manual audits and algo audits that, are done by bots, which are obviously less quality.
Actually, I'll tell you something. See, if let's say if we are following our process, and if we are making sure that each checkpoints that we are following is right, and we're giving enough things or enough attention to all those things, then we should be having like continued audits, like, or something like penetration testing that we can do it. We can have a certification from like an external party on our code. Okay, that we can do it. So I mean, we can do enough things, just what we can do, or how much our budget can give us, because we cannot put, as I told you, that we cannot put enough security controls if our data asset is not worth of that thing. So we need to make sure that how far we can reach, but that also that how much. I mean, the answer goes down to the risk management process that we are having, and it should be a continuous process.
Doesn't open source solve many of those problems with auditing?
Actually,
for people who are competent, but just for me, it wouldn't solve anything because I can't read the code. So I would still invest, not knowing. But for Taha, it would be better.
But you can rely on other people auditing the code for you. I mean, I cannot read the code of Bitcoin, but I do rely on the millions of people that are competent enough and are trying to break it.
Yes.
For my
one, I tell you for this thing. Yes, I tell you for this. If you want to go to an external party to review your code, you should have something like an SLA with them about, let's say if something happen or if bad occurs, you do this 1, 2, 3. Okay, whether you will be, or we need to. So for this, we are actually transferring our risk. We can have something like an insurance for our code. Okay, that if something goes wrong and if our user suffers, that this insurance company needs to pay out our users. Yeah, this is how we can control, or how we can mitigate the risk by transferring the risk. Actually, this is one of the practices.
Yeah,
Okay.
to me, it's not just about the actual smart contract code itself. It's about the whole environment, because you're generally activating a smart contract via a conventional web page. Okay, so you've got a conventional web page, HTML, JavaScript, etc., etc. Your smart contract, you've deployed the bytecode some time back. It's sitting on the blockchain. So you sending, let's say, some ether to a smart contract on the blockchain via a conventional web page. So there's a big vulnerability to me there, because it's not so much about the actual blockchain itself. It's about how you interact with the blockchain, you know?
Yeah. This was also covered in the MSc. I don't know if you took that module or which module it was, but it spoke about vulnerabilities with the reliability of oracles. So oracles have, you know, the task to bring this real world information onto the chain, but how reliable are they? Oh shit, Taha, I see your battery's low.
Yeah, can you give me like 2 minutes? Let me put my charging on, maybe, or
we have Marina commenting on what we are discussing now in the chat. So Taha,
Okay.
not sure if you want to.
Yeah, recording. Okay. So I think, yeah, this tag, I think you can see this. So if you see any link, which is any Ethereum or my Ether wallet proxy.com something, so you should not be clicking on this.
Yep.
And this is, by the way, it's like exactly the same Ether page, you know. So just make sure that what URL you are putting in your browser needs to be well protected. And there is also one practice you can do over here is like you can use isolated browsing, like in this way, because normally antivirus software that you use comes with like an isolated browsing feature. So this will take you to actually what the browsing thing, and if there's any phishing attack, or if there is or you're putting any URL which is not safe, it will not lead to you to that website. So that's one practice that you can do, use isolated browsing. Okay, so to understand this thing further, let us see the data flow in blockchain. So if you just have a look on this diagram, you will see that there is one guy who is accessing it can be a user, or it can be anyone who is accessing the network. He can either use a front-end web service, he can go to an exchange, or he can use a dApp, a normal dApp, to access the blockchain. Okay, so what do you think that what sort of vulnerabilities, or if you need to do some threat modeling in this figure, what of attacks that he can face, or any vulnerabilities he can face? What do you think?
Are you sharing your screen? Because we can't see your screen.
You cannot see my screen?
Yep.
I can see the screen.
Me too. I can see Marina showing up on my screen.
Wakas, you need to search in the gallery of participants, find Taha's screen and double click that. You have Marina pinned.
Oh my God.
Probably from
I think everyone can see the screen. Wakas, you can reopen the page or check your Zoom. Maybe there is some option to view the screen.
So Taha,
please go ahead. I'll figure it out. Thank you.
Okay. Dear Alexis, you were saying something?
Probably man in the middle attack, or maybe phishing. Those
yeah. So here, let's say if I'm using exchange, and if I'm communicating this to an exchange, and if there is an intruder or a bad guy over here who's a hacker, if he's using the same IP of an exchange, or if that exchange has a denial of service or comes under attack, so there is a spoofing attack that is a possibility which can come. So he think that, okay, I'll be talking to the same exchange, but it will not be the exchange. Okay, or if his access control is compromised, so that anybody can take, or the attacker has hacked his machine, Okay, he can take an access of this machine and he can go inside the. Okay. So there are multiple things. If we let me just put it like yeah. So we can see that we need to see once we deploy our architecture. Okay, you will see the blockchain is over here. Okay, but this all things, which is a dApp, it is a browser. You have cross-site scripting over here, or any attack which is which is targeted for a front end thing. Okay, or there is an escalation of privileges which can happen under this if it's not in under, or if let's say if this cold hot storage, okay, if it's having a denial of service attack, this can be, or this will not be available anymore, you know. So we need to make sure that what architecture that we are having with respect to the incoming flow of our data, we should draw this thing first. Okay, and then we able to identify that, okay, this guy can having an access control issue. If this guy went on vacation and if he's the only administrator, okay, then we should have a backup for him. Okay, or if let's say if he's running an important command, then he should not be only running it. We should have something like a multi-signature thing. Okay, so this is once we draw an architecture, we will be able to size up that what we need to protect. And then what we need to protect will comes down to what is our focus. Are we focusing confidentiality over? Because if we need to focus all the CIA thing, will we end up spending too much and will not be too much focus. So what the point over here is that we need to do something called a business impact analysis about each node, that if this front WAMP service goes under attack, what sort of loss I need to have it, okay, or what sort of loss that I can face. Then what sort of exchange, what sort of money is being, you know, having on the exchange thing, you know. So we need to size up this whole thing. Then we need to figure out what sort of attacks can occur in this whole round. So if you talk about from a centralized system point of view, here we see that usually in a centralized network, we see an administrator, then it is having a public DMZ, which is you know, having a web server for the public. Okay, and then we'll be having different firewall over here. And then if the attacker needs to reach to this level or to this layer, he needs to go through different layers of security over here, you know. However, if talking about a decentralized network, if you are not paying enough attention, then he needs to just bypass this guy, okay, or bypass the certified authority or a network administrator who is actually for a com, or if you're having or under context of private blockchain, if you need to just or bypass the participants, he can have an access of the whole network, and he can do multiple things in each of the domains. Okay, so what we need to do in this one, is that we need to focus on the security aspect the same way as we focusing on the centralized system. That we should be having the firewalls. If we are having our dApp, which is accessing our database, he needs to have the proper ACL or like the access control list that we need to, that what sort of source IPs I need to allow. Okay, if we are having one administrator, then we should be having multiple administrators with respect to, or with having any job rotation policy, you know. And something like if we are having a network nodes over here, you know, we should have enough redundancy if one of our node goes under attack, you know. So we need to have different things, or we need to think of like as if we are protecting our centralized network. Okay, so just think about, I asked you, Alexi, about, you know, what sort of things that we are having in this. So this threat modeling technique is like, it's basically what we are doing. We are mapping, we are using a stride technique. Stride is, let me show you or put it like this. This is, by the way, threat modeling technique, which is stride over here, which we call it stride. Stride is spoofing over here. Okay, then we are having something called that. Okay, tampering over here, tampering. We have non-repudiation over here, and then we are having data disclosure. So this is how we can map these things into our architecture. Okay, using this stride methodology. Okay, so spoofing is, as I told you, that if I'm having the same, if I want to access the exchange or end node, if this is under attack, he'll be using the same IP. So the administrator will think like, okay, it is coming from a known service, but this is under, or this can be under. Okay, So this is what spoofing is. And for the data disclosure, if he needs to, or if he's doing any authentication over here, authorization, then this thing needs to be encrypted over here, which is like the data in transit. Once he's transmitting, or once he's dealing with web, or once he's doing any configuration, that data transit path needs to be encrypted as well as authenticated. Okay, because if, let's say, if it's only encrypted, and if the attacker can get a hold on that encrypted thing, he can use a tool like brute force or rainbow bills or rainbow table to actually decipher that encrypted thing. Okay, so however, if you're having multiple things, like say that we are having encryption as well as we are having authentication. So in that case, once the attacker can, or once the attacker can get a hold of that encrypted thing, then he also needs to go through an authentication procedure, okay, to actually decipher that thing. So which is having multiple controls. So this way we can protect this thing. And then so there's one term over here which is non-repudiation. So do anybody know that what is non-repudiation, or what do we call like or what we call as non-repudiation? Is there anyone? It is also one of the important things in security. What is non-repudiation? Let me explain you. So non-repudiation is, if let's say if I am using a terminal, if I am causing, and if I have given my administrator access to anybody else, or to somebody else, and I am doing some bad thing, or if I am doing some attack, okay, the centralized server or the party who can prove me that I've done this action, like if I'm matching the actions to the subject, then this is non-repudiation. Okay, like if I'm making sure that whoever is, or whatever whoever are my participant, if I can be able to prove that if he's the guy who has run this command, or let's say if he's the guy who has come under attack, if I can able to prove that thing, then I'll be able to have non-repudiation in my network. Okay, so if there is a machine, or if there are multiple nodes involved, I need to make sure that the identity that they're using is mapping to their IP, or I'm using something called like I'm having something called digital signatures. Yeah, you can have something like digital signatures. Yeah, please.
Can you hear me? Yeah,
Yes, I can hear
your
you.
signal is breaking up a little bit. Can you hear me?
Yes, I can hear you.
Yeah. So is non-repudiation, is it like
Is mapping actions to the subjects. So, actually, your voice is breaking up.
About Bitcoin?
Your
hear
voice.
Me? Can everyone else hear me?
I can hear you now. Yeah.
I think that Taha is breaking up. We can hear you fine, Alexa.
Yeah, Taha, it's your side, the signal.
Let me see that. Is it fine now?
Yeah.
It is fine? Is it okay now? I've changed my position. I think. Okay. So what I'm saying, non-repudiation is if I'm mapping my actions, or the actions to the subject, that who is doing this thing. Or if I'm, let's say, if I'm having multiple participants in my network, I can be able to prove that whatever actions or whatever access they are having to an object is being identified, and I can prove that. If let's say, okay, if Alexis, if you are running a command, okay, and that command causes a downtime in my network, I can be able to prove that you are the one who have run this command, and you cannot deny it. Okay, so if I am able to prove that thing in my network, I'll be able to have non-repudiation in my network. And this way, I can be able to have a good access control in my network, you know? So the technique,
right?
Yeah.
Yeah. Every now and then you hear like half of his sentence, but not fully.
Yeah.
I think it's, I don't know, internet connection is not, yeah, I think I'm not sure. Let me
change my position. Just hold on 1 minute.
Okay, sure.
Yeah, just. Is it fine now?
Yeah, maybe would that help?
Yes, I think you can do this thing.
Yeah,
Okay.
it's better.
It's better. Okay, so do you have, so what I was explaining? Okay, non-reputation. So are you okay with non-reputation thing? What do you want me to explain?
Yeah, I just wanted to ask, is that?
Yeah.
Is that what happened with the Twitter attack last year when the celebrities and politicians were all tweeting about free Bitcoin?
No. That is the spoofing thing, because this is a falsifying identity. So non-reputation is like, what we are having digital signatures. You are digitally signing or using your private key to encrypt your your transaction. So this is, you are proving your identity.
Okay, got you.
Okay. So this is what non-reputation is. So whatever I am having in my dApps or what system I'm using, I can be able to prove that, okay, these are the systems which are generating that transactions. It is a way of authenticating in a network. Okay. Okay. So if I'll just map all of those attacks from like the denial of service attack or the data tampering or the spoofing attack into the actual impact, that what impact it all cause, because this methodology, what I'm using a stride methodology in threat modeling. So this way I can be able to size the impact, that what sort of loss it can happen once all of this attacks is mature or realized, So that is, let me show you. Okay, so this one, if there is spoofing attack, which is falsifying identity, okay, I can have identity theft, my data loss will occur, a secret channel will be broken, and this way, if I'll be having a data tampering, so all of these things attack, all of this impact can occur. Okay, so in this way, I can be able to size up that once I'll do this threat modeling into network, okay, this is what sort of things I need to have it. And in order to protect all of these things, you need to then again do the risk or the risk impact analysis. Like, if for the spoofing attack, if my identity theft is being done, if my, let's say, if my administrator or if my important node is compromised, what sort of damage it can occur. Okay, then I'll be thinking about putting or how I can mitigate that thing. And similarly, for, let's say, for data disclosures, if my secret channel is broken, my data will be disclosed. And what sort of data loss prevention tools I need to have it. If it's related to the code thing, what sort of things, if let's say, if my source code is being compromised, or if there's any important logic which is bypassed, so what sort of data I need to make sure, so that I need to have like the encryption in my data, which is on rest, and in transit. So this is one of the good practices that we can follow. So okay, just dividing a blockchain into different security domains. What we can think of, like, okay, this is an endpoint security in which what we can do, we can give training to our users. We can see something like, we can put like, how you are controlling your cryptographic keys, where you are storing it. Okay, how you are accessing your network. We can put controls over here, let's say, something called ACL, that we are having different IPs which can only use to access the system. Okay, and if my, let's say, if my administrator is having root account, okay, that account needs to be given, or if he's using some important commands, then he needs to have some, something called multi-signature, in which different parties should be involved in this, And talking about front-end server applications, here there is one good website, which is owasp.com. It will tell you like the top 5 attacks that is been going around in the space. Okay, which with respect to mitigation strategy, respect to the impact, all of these things. So this is how you can protect your front end server applications. Okay, and then for the blockchain platform itself, what you can do is that, so
So for the blockchain platform, what you can do, you actually synchronize the data on each of the nodes. Okay, plus you make sure that the data is consistent. So the main thing what blockchain is controlling is integrity of the data. Okay, which is immutability. How about confidentiality? Like, how the nodes are accessing the data, or let's say if I'm having, let's say, okay, 10 nodes in my private blockchain network, that whether I'll need to make sure that if my actual transaction flow, if my one of the nodes is compromised over here, okay, how my network will be keep functional. So for need to make sure that for each of the security domains, I need to first size up using the threat method, using the methodology, and then divide each domain into different domains. And this is how I'll be able to protect my network. Okay, coming down to the blockchain secure deployment process. What are the things that we need to take care of? Okay, the first thing is acquire blockchain expertise. Here, if in your team there is already a person who is good in cybersecurity, okay, then giving him the blockchain knowledge or educating him with blockchain will be a good option. Okay, rather than taking or educating the blockchain guy into cybersecurity, because the cybersecurity is itself a broad domain. Okay, and you cannot teach someone, like say in 2-3 months or 6 months all of this practice. It comes with experience. So it is best to have the cybersecurity guys in your team with prior cybersecurity experience, then giving them the blockchain. Okay, and the second step is define security goals. What is your goal? Are you protecting confidentiality? Are you protecting integrity, or non-repudiation or availability? Okay, this you need to make sure in your, once you are setting your organization or setting any architecture, you need to put it like on the governance model, like, what sort of things that you're protecting, what should be the procedures if your nodes comes under denial of service attack or the distributed denial of service attack, how will you respond to it? How will you isolate your system? So this is, you will do once you have the goal set up and right. Okay, and then configure blockchain. You need to what sort of protocols you need to have it, if what sort of latency, what sort of network you need to have it. Yeah, so this is the configuration process. We all know that we are having a good expertise in the configuration part. So the coding thing, just need to make sure that the smart contract coding is taken care of as a process, from like the initiating till the development cycle, testing, all of these things we need to take care of. Okay, performing risk assessment. In this one, what you can think of is to create a scenario. For instance, if let's say, if you're having a blockchain network for any use case, if some of the nodes are compromised, what sort of impact I need to face it. Then you need to put the controls appropriately. Or if let's say, if my confidential data has been compromised, how I'll be, or what sort of risk I need to, or what sort of loss I can have it. So this is, once you performing risk assessment, it giving you a good picture. Okay, then security controls. Over here, there are 2-3, or all the security controls goes into 3 domains. One is the administrative control, in which you define the policies that what you will do once this risk, or once this issue matures. Okay, then what sort of technical controls you need to have it. Technical controls includes firewall, includes ACLs or the security groups, all of those things, encryptions, all of this comes into the technical control. Then security governance. I told you that governance comes with like a top up approach, like you need to have your senior management approval with this, and you need to have all your procedure documented in your governance framework. So develop securely. This is actually one of the same thing, like for the development, you need to follow the software development cycle, from like the initiation till getting the functional design planning stage, then doing the SSD of your in your or your planning thing, then all the way going to the testing. So you need to follow the software development cycles, and security should be there in each of the steps. So this is about it. For the recommendations, sorry, I have taken a lot of time. Just for the recommendations, Okay, make sure that for the phishing and social engineering attack, you are more, or you are, more familiar with this, and don't click or don't make sure that if you're having your private keys, you should be having securely not on your mobile phone, or if you're securing on your mobile phone, then it should be encrypted. Okay, then you'll not be disclosing anything. Make sure that your or if your fellows or whom you trust, you need to have a proper backup mechanism that, how will you restore if you lost your private keys. Okay, and the cryptojacking, like if you are your browser comes under attack, which is being used to mine, or you should have proper extensions in your browser. You should have your antivirus up to date. Or you should be having, let's say, you should be, storing or storing all of your, or the keys related to an offline wallet. So this is one of the things. Software flaws for the wallet and for the dApps. Most of the attacks are well known, okay, for the software industry. Okay, but as I told you that you need to have, or you need to do your due care and due diligence. If something goes wrong in your architecture, you will be the one to be blamed. Okay, you cannot put your blame like, I have used an open source code. This is why this attack happened, because it can be a possibility that your network will be used to attack any third party network. Okay, so that if there's a prosecution that will happen, it will comes down to your neck. Okay, so you need to make sure that all the software flows are well taken care of, and if you are doing the due diligence, then you will be in a good position to protect yourself. Okay, when it comes to the regulation, and once there will be a prosecution thing. For the solution, cloud solution deployment, I would suggest to because security is not easy, or it's not free. Okay, you cannot have enough adequate measures, or you cannot protect your network fully. So cloud solution deployment will give you the chance to outsource your security controls, and there are very good tools available in, let's say, in AWS and Microsoft Azure, which can give you end-to-end security from like creating your cryptographic keys to actually managing all of your keys, to actually giving you the firewalls, or the or to detect the security thing, all of those things which comes in a security lifecycle. All of those platforms will give you each of the thing, and it's like, pay as you go model, so it will be cost beneficial for you. Yeah, so that's it. If you have any questions, please do ask. I'm sorry, you have faced some interruptions due to battery issue and these things.
Thank you, Taha. That was extremely interesting. I don't have questions. I was asking them throughout, but that was great. Thanks, Taha. Anyone else?
No problem. No problem. You're welcome.
Yeah, I think I'd like to just say it's a big topic. I think it's bigger than a lot of us realize. It's not just about the security of the blockchain itself. So yeah, it's very interesting. Thanks.
Okay, thank you, everyone.
Thank you, Taha.
Thank you very much, Taha.
Thank you, Alexa. Thank you.
Taha, are you still here?